Hello, so we are doing Math 2 Part 2. We're going to go a little bit more into significant figures, but using scientific notation and converting. All right, so thing to know about scientific notation is that there's two parts. First part being that there's a number between 1 and 10, which contains only significant digits of the original number of the one that you are making the scientific notation from. Second part is it has the exponential, or the power of 10, 10 to the n. Positive is greater than 1, where n is greater than 1, and negative is where n is less than 1. And you can see this on the front of your reference table. Some of you are using it earlier for conversion, so don't forget about that. So first things first, we're going to expand it out. One thing I want you to know is all of these exponentials, all these scientific notation has it where there's only one number in the front with the decimal next, and then a number or numbers after that. So bear that in mind when we get to the next part. So this first part, remember what I said about the jumping, right? So this is where jumping comes in really handy. If it's positive, it goes to the right. If it's negative, it goes to the left. And yep, there we go. So the first one we have is 2.5. And what you're going to do is, because it's positive, you are going to go to the right. So I'm going to take that decimal and I'm going to jump it 1, 2, 3. And it's going to make 25,000. Okay? The next one, -3. So that means I'm going to go to the left. So I'm going to take this decimal and I'm going to jump it 1, 2, 3. Adding zeros right there. So it'll be decimal 00650, right like that. That's what it would look like. Next one is my favorite because it's a 4.5 times 10 to the 0. 10 to the 0 means you are jumping 0 times. So it is just 45, 4.5. All right, the next one is a positive. Positive goes left. So I'm going to take this decimal, and I'm going to jump it 1, 2 times. So you should get 983.09. Next one is a -1, so I'm going to the left 1. Jump it 1 over here. So you should get 0.981. And then the last one is a 3. It's positive, so I'm going to jump 1, 2, 3. And I'm going to write down, and this is going to be a little tricky, because remember where the rule, number 4, there's a decimal, you got to count it. So I would write that down, 1200.0. That 0.0 has to be there because of significant figures. All right, so we're going to rewrite this in scientific notation. Now, how to do this? This is my trick to you. You can write it somewhere if you have to. Big is positive, small is negative. Keep that in mind. And remember what our trend was right here, in between the first two numbers all the time. So when I do this, I'm going to need to make it in between these two numbers. These two, these two, these two, these two, these two, okay? So first off, it is small, so it's going to be 10 to the negative jump. So I'm jumping 1, 2. So it will be 5.4 times 10 to the negative second, or 2. This one is going to be in between these two numbers. So I'm going to jump 1, 2, 3, 4 times. It's big, so it's positive. So I'm going to put a 1.034 times 10 to the 4th. Okay? This next one is 89. I'm going to jump once to in between the two. So it's going to be 8.9 times 10 to the 1. All right, so 600,000. I'm going to jump 1, 2, 3, 4, 5. It's big or over 0, so it's positive. So it's going to be a 6 times 10 to the 5th. And you notice that I didn't put any zeros. Why? Because the significant figures in Rule 4. There's no decimal, so it's just the 6. All right, so I'm going in between 2. And it's small, so it's going to be negative. So I'm jumping 1, 2. And I'm going to put 1.00 times 10 to the negative 2. Now, why did I add the zeros there? Because of Rule 4. It's after the decimal, these count. But Rule 2 means these don't. Last but not least, 2.3, my favorite, 2.3 times 10 to the 0. All right, so the next thing we're going to look at is dimensional analysis or factorial label. That's a lot of technical terms for just saying conversion. All right, so the first thing we're going to convert is 6 inches to centimeters. So put up your T and plug in where you need to. So you know there's 6 inches and you're going to centimeters. So you're going to want to plug in your numbers because numbers and units are equally important. So always write your units in there. Write down the information that the problem gives you. What you are given on the left, what you want on the right. Just like that. Next step, you're going to plug in these numbers and you want to get rid of inches. So whatever you have up in this corner, you want to put down in this corner. I'm going to put inches over here. And then I'm just going to plug in the numbers that match. So it's 1.00 inches to 2.54 centimeters, just like that. And yes, you can use the way they have it put, or the way that it is put in here. But I like my little box because it makes things nice and easy. So I'm going to cross out there. So the inches go away and I'm left with centimeters. And just to reiterate what I did, the unit to be eliminated is in the numerator. You need to put the unit in the denominator of the next line. Okay, so following, you multiply out. So I multiply the top, and when I do that, I get 15.24. But because there are 3 significant figures throughout all of this, and we are multiplying, dividing, so I need 3 here. So I'm going to use the rounding. I'm going to round, or I'm not going to round down, but I'm going to stay the same because that 4 is less than 5. Sorry, it's being really weird about. It's less than 5, so it's going to stay the same at 15.2 centimeters. All right, so we did the first one. Second one is 120 centimeters to meters. You can do this again. Meters, centimeters, centimeters. 1, 2, 0, decimal. So there's 3 sig figs, so your answer has to have 3 sig figs. So you put that down. There's 1 meter to 100 centimeters. So I divide 120 by 100. I get 1.20. And I have to have that 0 because it's sig figs. All right, how many millimeters are in 12.6 kilometers? A lot of you got confused on the check for understanding. So this is how you would do it. So I'm going to go from kilometers to meters because I got to get to the base before I go to the negative. So there's 1 kilometer equals 1,000 meters. I got to get out of meters and I got to go to millimeters. So I'm putting meters on the bottom. Sorry, meters on the bottom and millimeters on the top. Meters are bigger than millimeters, so 1 on the bottom, 1,000 on the top. And it's going to be 1, 2, 3, 2, 6, 2. Yes. So you should have that. Or in scientific notation, should be 1.26 times 10 to the 7th. How did I get that? I jumped 1, 2, 3, 4, 5, 6, 7 times. And it's big, so it's positive. So 1.26 times 10 to the 7th. This next one is very tricky. I'm going centimeters per second to meters per hour. So I'm first going to write down 15.5 centimeters over 1 second. That's when you have the division and there's just a letter there. That means there's one of them. There's always going to be one of them. So I got to go to this and I got to get meters and hours. So first off, I'm going to convert from seconds to minutes, minutes to hours, okay? So there are 60 seconds to 1 minute, right? Come on. Which means I can cancel out my seconds. And I got to go from minutes to hours. 60 minutes to 1 hour. My minutes cancel out, and I'm left with hours. I want hours on the bottom. That's perfect. That's where I need to be. But now I got to get the centimeters to meters. So how do you do that? Well, over here, I'm going to put my centimeters down here and my meters up top. I want meters. My centimeters cancel out. I'm left with meters per hour when I get my final answer. And there's for every 1 meter, there is 100 centimeters. When I multiply the top, oops, sorry, I dropped it. I get 55800. And I'm going to leave my meters up top. And I got to divide that by 100 hours. And when I do that, I get 558 meters per hour. If you have questions on this, please ask me. We're going to be doing some conversions, lots and lots of conversions, especially in stoichiometry. So if you have questions, ask. Don't hesitate. Somebody probably has the same question. All right? Besides that, I hope you guys have a great day.